is x bar 1 minus x bar 2 over the root of S1 squared over N1 plus S2 squared over N2. So if we substitute, it will be 69 minus 65 all over the square root of 2,5 squared. Remember now, it is given as standard deviations, but we want the variance. Therefore, we must square up the standard deviation. Over N1, it said each is 50 plus S2 is also 2,5 squared over 50. And when we do our calculations right, this should give us an 8. Right? And then it is a one-sided test, so it's 1 minus alpha. So it becomes Z1 minus 0,05, and it is a Z of 0,95, and this is equivalent to 1.645. So now we are able to decide when we know, since the calculated value 8,0 is bigger than the critical value 1.645, then the null hypothesis is rejected. And we can conclude the mean height of males, males exceeds, because we rejected up here, exceeds that of females. At 5% level of significance. Correct. There we go. Done. You got your 7 marks. You got it right?
Yes, sir.
Ah, beautiful, beautiful. 7 marks. Okay, we're going to go to the next one. If there isn't any query or question here, or just any comment, we're going to go to the next one. All right, let's go to the next one. The next question, question 6. Question 6. Here is question 6. Sorry. A transport sub-council wanted to know if there is a variation in the commuting time to work between the bus and train commuters. They conducted a small-scale survey amongst the bus and train commuters and computed the following descriptive statistics for each sample commuters. That's your bus commuters and your train commuters. The sample means, the sample variances, and the sample sizes. At 5% level of significance, is there evidence in the variation between bus and train commuters? Assume that the commuters are normally distributed. Is there variation? So you're testing for the difference in variation here. And remember, when you do that, you need, if you do variation, you need an F distribution for your test. If you're testing for the difference in variation, you need an F distribution. Please give it a try, one. Let's see how much you'll get. Thank you. For 6 marks, this should take you less than 5 minutes. Assume that what is wrong here. Committers are normally right. There we go. Please give it a try. Five minutes. right, now for a solution, let's check on the solution for this one. Okay, let's do this. All right, you're testing for the difference in variances here, and your null hypothesis will be population variance 1 is equal to population variance 2. And your alternative is population variance 1 is not equal to population variance 2 because nothing was said about big or small. So it is not equal to, it's two-sided. And we're testing at 5%. So it's 0.05. And because it's variances, it uses the F distribution. And the F distribution is variance number 1 over variance number 2. Remember we said of the variance is the one with a larger variance. It's going to be the numerator. So this becomes 7.8 over 4.6. And that should give you 1.6956. Right. That's your step number 3. Step number 4. Now for the F critical, it is F N1 minus 1 semicolon N2 minus 1 semicolon. And because it's an F distribution, we said it the other day, it's only using alpha on 2, not 1 minus alpha like we had before with the others. So it is F. N1 is how much? It's 21. So it's 21 minus 1. And the other one is semicolon. It must be a semicolon here. Semicolon. Oh gosh, what's this now? Semicolon here. And N2 is 26 minus 1. Then alpha is 0.05 over 2. So this becomes F of 20 and 25 and alpha of 0.05 divided by 2 should be 0.025. Right? And if we read this off the F table, it should give us 2.3 from F table. I want to bring the F table. Keep this one. I want to bring the F table so that you familiarize yourself with it. Right. Let's check the F table. Remember, we said the F table is a very long one, this one. It's a very long one, but you need to bring up all what you need. You're looking for F20. And remember, the first one, the first degrees of freedom are your numerator degrees of freedom. So the 20 should come along here as degrees of freedom here, or in the numerator. And the denominator should come along this there's no 25. We move on. There is now. There's a 20 here as your numerator, but there is no denominator. Look at the denominator here. There is no 25 as the denominator here along this column. Along this column, there's no 25. So it means we must move on to the next one again. Let's check. Now it's back to 1, 2, 3 up to 9. There's no 20. How much? 20 here. We move on until we come to the table that we want. All right. Again, as you look at the numerator, there's no 20 there, and the denominator as well, there's no 25. And this one, there's the 20. There's the 20. Let me enlarge this a bit. The 20 is here, but along the column or the denominator, there is no 25. Look at this. There's no 25 here. It goes up to 18. So we move on to the next one. Now again, the numerator, there's no 20. But the denominator, the 25 is here. But still it means we cannot use it because there's no 20 here along the numerator. We move on until we get the table that we want. Okay. Let's move on. This one as well, no. The numerator, there's no 20. What about this one? This one, same story. There's no 20 there. But there is a 25 of the denominator. And this one, now here is a 20. Here is a 20. And here is a 25. And remember, each block or each value here, each degrees of freedom, like 19, it starts at comma 1 up to comma 001. You know, the whole block from comma 1 up to 0,001 belongs to 19. So for 25, it starts at comma 1 up to 0,005. But what are we looking for? We're looking for 0,25 against 20. 0,25, it is here. The 0,25 is there. And we go now look, where is it intersecting at 20? It intersects right here at 2,3. Hope you can see this. All right. Can you see this? So I said, with this F table for variances, we won't give you the whole F distribution table. You know, it's got so many pages. We'll just give you the table or the page that contains your answers. We'll just be specific and give you the one that contains your answers. Right. That being said, now we can go back to our problem. And go to the current slide. No. What did we do now? That's right. So 2,3 is right. Then you are able to go to step number 5. And step number 5, now we look at the calculated value. Since 1,6956 is less than 2,3, our critical value, HO is accepted. HO is accepted. And if it's accepted, then it means there is no variation. There is no variation. There is no parameters. And train parameters at 5% level of significance. There we go. Done. You got this one right? It is to know that if it's two-sided, This one is two-sided. The F critical is if it's one, the F critical is using alpha. That is, it will be F N1 minus 1, N2 minus 1, and alpha. This is one side. But for two, it uses this alpha on 2. Could you come? Hello? Is this on?
Sir.
Hello? Are you there?
Hello.
Hi.
Hi.
You have a question, ma'am?
No, sir. You were just wondering if your microphone was working. It's working. We can hear you.
Okay, beautiful. Thank you. Thank you so much. All right, let's do the next one. Actually, the last one. And people, I'm having a load shedding at 12 here. Let's see how we're going to do this one. I hope we'll finish it before 12. The last one is question number 7. Here is question for 10 marks. Oh. An investment company wishes to compare two companies they use to assess the value of residential homes. They selected a sample of 5 residential properties and showed firms for assessment. The results were as follows. Boni, and those are the values given. Give it a try, please. For the difference, I even highlighted the difference. Okay, we need to look at the solution here. Now panicking because there's a possibility of load shedding. Give the solution. Two values 135 minus 128. You should get a 7. Then 110 minus 105 is a 5. 131 minus 119, it's a 12. 142 minus 140